Hey chemistry students, Timothy McNeil here, and this is my big year experiment for chemistry. This will be due for checkpoint 4 and checkpoint 5. So for my experiment, I'll do a quick explanation. I'm going to take materials like glass and some metals and heat them up to about 200 degrees Fahrenheit and then expose them to cold water and see what that does to change them. Because I had originally thought of using plastic, but warming that up to that degrees may actually just melt it, and so I do not want to do that in my parents' oven because they will get mad. So plastic is out for the moment until I find a different way to do it. So our starting observations of the metals is this aluminum here. It's a kind of thick piece. It's pretty smooth, rather bendy. Then tin here is not so bendy. It's a thicker piece and rather smooth. Yeah, so that's rather smooth. And the glass, not bendy and smooth like glass. So I just threw the materials in the oven and I'll be giving them about 30 minutes to heat up. In the meantime, I'll explain a little about what is my hypothesis, and yeah, and then I'll pause the video and come back to you in 30 minutes. So my hypothesis is that they will change once I take them out of the heat and dump them in the cold water. They'll change in some way. Most likely they'll get weaker, but because they're already bendy and I do not have the precise measurements, I'm going to test more their feel and if they explode or anything like that, because that'd be pretty obvious. So right now I'm going to talk a little about thermal shock. It occurs when well, the Wikipedia article says it occurs when thermal gradient causes different parts of an object to expand by different amounts. So basically what happens when thermal shock happens is you get something hot or cold then hot, really sudden and really extreme, and then the crystal structure or the structure of the material changes and becomes less stable. And this will happen to break the things down and really degrade the durability. And that's what I'm looking for, and to see if that will happen between about 200 degrees Fahrenheit and then about 33 degrees Fahrenheit, because that's water's going to be pretty cold by then. So yeah, and I'll be back within a half an hour to show you guys the results of the experiment. Okay, so 25 minutes have passed. I am now dressed in lab equipment, long sleeve shirt so I don't get burned if anything happens, gloves, and safety goggles. So our original observaments, measurements of the materials were that the glass, which is our trial one, is smooth like glass. All these materials are very relatively smooth, and the glass is not bendy because if you bend the glass it will break. Then our trial 2, which is welding steel, is resistant to bending. It springs back into place and you can't really bend it out of shape unless you put in a lot of pressure. It's a lot thicker. This may be a reason for it. Springs back into place and is also smooth. The third trial, which is aluminum, it is very bendy. You can bend it out of shape rather easily. Aluminum is a very thin metal. And it is also smooth. And then our fourth trial, which is the plastic, which I'll be testing separately, is stiff. It doesn't bend very much. I can show you an example because it's not in the oven yet. It doesn't bend very much at all. And it feels as if you bend it, it'll break, so I'm not going to bend it more. And it is also smooth like the others. So we're going to be taking the metals out of the oven, and I will demonstrate that in a sec. So I'll be right back. So here's a picture of the sink where we'll be putting the metals in and glass, and I'll grab those out of the oven right now and you'll see the experiment. So I'll be right back. Here's the metal first. This is the welding steel. Dump that in there. Grab some tongs. Now this metal was at 200 degrees Fahrenheit. It's rather cool now. That was a very sudden temperature change. I'll set it over on a drying rack. I'll grab the next one, which is our aluminum example. dump this right in here. Slid in without a problem. Grab the tongs once again. Fish it out of there. My glove got a little wet. Water is still the same temperature, I think. I'm not going to test it with gloves on. I'll put that on the drying rack and grab our third metal. Test the water. Still same temperature. Throw the thermometer in there. Watch that real quick. Yes, no changing there. Grab our last metal, or our last one of this batch, which is glass. And this one may be the dangerous one, so I'm just going to slide that in there. Hopefully it did not break. I have had glass break before under extreme temperature change. This one, I do not think it actually broke, which is good. Pull that out. Take it with a knife. Okay, and I'll get back to you on what the experiments found. Thanks for watching. None of the materials changed in that one. They all were relatively the same. There was no noticeable features that were different. The only thing that I could notice was the aluminum was a little bent out of shape. It was in a kind of curvy. And because of that, I'll be starting trial 2. And we'll see at 300 degrees Fahrenheit if it undergoes any change there. While we're waiting for the second batch to heat up, I thought I'd explain a little about the benefits of this experiment. For one of the things we were asked to think about how this would help society. Well, this may help people who deal a lot with heated temperatures, such as smithies, where you always see in the movie where they take the metal and dip it into the oil or something else which is cooler than the actual metal, so that could deal with them and help explain why sometimes the metal is less durable before it or after it's welded than before. So that could help in that branch, and also could help people like in Antarctica or other places like volcanoes dealing with extreme hots and maybe then extreme colds. So like Iceland has volcanoes and cold temperatures sometimes. So things like that could also help in just like durability of materials, because you don't want your equipment like suddenly breaking on you because it got really hot then really cold. So those are some of the benefits of this kind of experimentation for the world and people out there using it. So I'll get back to you when we're ready for trial 2. So here we are after trial 2. The plastic, metal, or steel and aluminum have not changed at all. A little wetter now that they've been in the water. But the glass, after it was heated up to 300 degrees, when it was put in the water, it immediately shattered. So that rules that out. So changes from 300 down to cold water for glass shatters it, which can be very helpful. So that's the observation, and stay tuned for trial 3. After inspecting the shattered glass a little more, I find that the durability definitely did change in the pieces that are still intact. In fact, I'll show you. I don't know how much you guys can tell, but in this piece of glass, which is part of the whole one, there are shattered or cracked lines lacing the whole thing, and if I put too much pressure, which I won't because I'm holding it in my bare hands, parts will break off. So the durability definitely was affected. For the other materials, 300 to cold water was about 35 degree temperature, I think is what the water's at now. That didn't change it much. The aluminum is a little more springy than it was, but I don't know if that's just how it feels when it's cooled down. So I think it is about the same though. So there's not much change within the other things. I hope the plastic doesn't melt in this one, because that would mean that 400 is too hot, and above that, cooling it down really doesn't matter because the shape will change. So stay tuned for number 3. So after setting off the fire alarms because of smoke from something that was in the oven that I hadn't been aware of. I finished and completed my third and last trial. Now, in that trial, the plastic melted, and so it was like bending kind of over. So I grabbed it out, I tossed it in the water, and now I'll show you what it looks like. It's got this kind of shape to it. It used to be a flat piece, as I showed you guys, and now it's all wrinkled. Give you guys the 3D, and if you guys can see up here, it's rather bubbly now. This little kind of white looking area is bubbles, and so that definitely changed the durability and structure, because it's well, it's a little bendier in certain areas, and it's got bubbles, so it's definitely less in the shape that it was, and probably damaging to whatever you needed it to be. The metal, the welding tin changed color, and both metals, aluminum and the steel, became a little stiffer than they were before. And since this is my last try, I will not be heating them up anymore, because actually, you know, let's go for one more try with the metal. I'll throw in one more. We'll go up to 500 and see if they change. I believe my hypothesis for this last try is that they won't, because they won't change their durability. They may change color a little. They simply won't change because metals require a lot of heat to melt them, and to get close to a point where the sudden temperature changes would affect them, they probably need a lot of heat, and I cannot generate that much with a simple kitchen stove. So we're going to go to 500, and that will be the last one for tonight, so I'll be right back. So trial 4 is done. At 500 degrees, the metal, I'll start with the aluminum, which is right behind my computer. The aluminum is mostly the same. Its color has not changed. It's a little less bendy than before. I could usually bend it a lot more, but now it's a little bent, but I think that was from bending before. It's a lot springy. Springs back into place. Not much change in that case. On the other hand, the steel became a very nice shade of brown and purple. Just has some pretty nice colors on there, which was very surprising. Got a napkin to wipe this off so you guys can see the colors. There we go. There. So yeah, that one, it's very, very tough to bend. It was a lot more bendable earlier. You can't really bend it at all now. So it definitely became stiffer. That means it won't be able to absorb shock as much, which might cause damage to things like springs and stuff that needs to absorb shock. And it changed color. It's not, it's still smooth. There's not much change between the metals, between their springiness and I guess their color. So I believe to make those change as much as the glass and plastic changed, I need much higher temperatures. The plastic, as on turn 3 or trial 3, definitely became bent out of shape, and so about 300 degrees or 400 degrees is the plastic's maximum like melting point, and it'll definitely do badly under hot and cold temperatures there. And under 300 degrees, the glass will shatter with extreme temperature changes. Some safety rules, if you guys ever try this experiment, make sure that you watch the plastic very carefully, because it started melting, which does release toxic fumes. So we're kind of airing out our house now, just in case any fumes got out. And in chemistry, whenever you're doing stuff, you have to be very careful with ventilation, because if you get dangerous chemicals, they could hurt someone very badly. And especially with heat stuff, chemistry is always very dangerous. So I wrote these things, all my findings and hypotheses, in a paper, and I'll be turning them in with this video. So thanks for watching my recording, and I hope you enjoyed. See you guys later in class.